We know that the properties of an image formed by spherical lenses vary with respect to the object's position. One of those varying properties is the size of the image. But what if we want to compare the size of the image with the size of the object? We have a term which relates the size of the image with the size of the object, and it's called magnification produced by a lens. It's defined as the ratio of the size of the image to the size of the object. It's denoted by m. Mathematically, we can write it as m is equal to the size of the image over the size of the object. But in our ray diagrams, the sizes of the image and the object are nothing but the heights of the image and the object. So this ratio is nothing but hi over ho, where hi and ho are heights of the image and the object respectively. Okay, now let's quickly consider two cases. The first case is when m is greater than 1, and the second case is when it's less than 1. When it is greater than 1, it means hi over ho is greater than 1, which implies hi is greater than ho. And what does that mean? If the ratio is greater than 1, the size of the image is greater than that of the object. Or in other words, the image is enlarged. What if the magnification is less than 1? Then the size of the image will be less than the size of the object. The image formed in that case is diminished. Now answer this question. What will be the magnification produced by a concave lens? Well, in case of a concave lens, image is always lesser in size compared to the object. Hence, the magnification for a concave lens is always less than 1. Now, there is one more concept left in this chapter to explain, and that is the power of a lens. But before jumping onto this new topic, we need to understand something. What if rays of light parallel to the principal axis are incident on the convex lens? Yes, they will all converge at the focal point. Now consider another case. Say I take another convex lens which is thicker in the middle than the previous one. It has its principal foci situated here. Now, as the lens is thicker, the focal length of this second convex lens is lesser than the first one. What will happen if the rays of light parallel to the principal axis are incident on this second lens? Nothing extraordinary. They will also converge at the focal point. But observe both the cases carefully. Is there any difference that you notice? In the second lens, the light rays are bent more than in the first case. Yes, the light deviates more in the second case. Something similar happens for concave lenses as well, just that the rays will diverge here. If we take two concave lenses, one thicker than the other, then the lens which is thicker will bend the rays by a greater angle. With this in mind, let us now define the power of a lens. The power of a lens is defined as a degree to which the lens deviates light. Can you tell me what it will be dependent on? Yes, the power of a lens is related to the focal length of a lens. Or we could also say it's dependent on the thickness of the lens. And what could that relation be? Well, we have seen that when the focal length is less, the lens deviates the light by a greater angle. Lesser the focal length, more will be the deviation. Similarly, more the focal length, lesser will be the deviation. So can you tell me the relation now? Yes, the power of a lens is the reciprocal of the focal length of a lens. P equal to 1 over f. The SI unit is diopter and it's denoted by D. And in this formula, f is the focal length in meters. Let me ask you a simple question now. When will the power of a lens be 1 diopter? Yes, when its focal length is 1 meter. One more thing is that the power of a concave lens is considered negative and the power of a convex lens is considered positive. This is just a convention that we follow. Let's take a simple example to understand it. Say I have a convex lens of power 2.5 diopter. What will be its focal length? Well, the first thing we must note is the positive sign. The power is positive because it's a convex lens. Its power is positive 2.5 diopter. We know that P is 1 over f. Taking the reciprocal on both sides, we get f as 0.4 meters. This means that the focal length of this convex lens is 0.4 meters. Will it be positive or negative? the focal length will be positive as well. Why? It's because, according to sign conventions, the focal length of a convex lens is considered positive.